Here we come to A-Level Physics 2012, question 7. Here we have a small ball projected from point O on the ground with a certain initial velocity. We don't know about the velocity, so let's make it u. So this ball is projected and follow a projectile motion. It reaches its higher point at point P, and then it continues to fall back to the ground. At highest point P, there will be no vertical velocity. The ball will be flying horizontally, so let's assume the velocity is v. Here, the question asks us to find the magnitude of change in momentum. Let's remind ourselves what is momentum. Momentum is given by mv. So the change in momentum is given by the change in this product, m times v. However, because we are talking about the same ball, the mass will be constant. So the change in momentum can be expressed as mass times the change in velocity. We can see that when the ball goes from here to here, from O to P, the velocity change from u to v. Okay, and we would like to see what it would be the change in velocity, delta v. And we can put in delta v, we can then calculate a change in momentum. However, in this question, because of the lack of information, we do not have much information. For example, we do not know the initial velocity, we do not know the final velocity, we do not know the distance between the projection point and the landing point. We have not much information, and we also don't know the projection angle. So in this case, we have to consider like conservation of energy. And here, conservation of energy still holds because there is no work done in the situation. So let's try to consider the conservation of energy. By the conservation of mechanical energy, we can say that at point O, there will be no PE, so we can write down as mechanical energy as 1/2 mu square. It only has KE. And when it goes to point P, it gains PE, which is expressed by mgh plus a part of KE because it's still moving, so half mv square. Don't forget one thing, that is, for the initial velocity, we can also resolve the initial velocity into its horizontal component, ux, and vertical component, uy, respectively. One more thing is that because we know that the horizontal motion is a uniform motion, so basically, ux and v, they are basically the same. We can write that down. So we can put in the numbers. Let me write that down. Ux is equals to v. Let us remind ourselves, because the horizontal motion is a uniform motion. Let's put in the numbers. We know that m can be cancelled out on both sides, so don't need to worry about that. So I want to multiply 2 to the both sides of equation so that we do not have the fraction 1/2. So we got something like this. 2 times g times h plus v squared. Okay, and one more step. Here, note that I have changed the v into ux, and we'll see in a minute why I am doing so. Next, okay, here in this equation, we have two unknowns. We don't know what is u, we don't know what is ux, so there is no way to solve this equation. However, we can consider here, and we try to write one more equation relating u and ux. And then we can try to solve the simultaneous equation with two unknowns. Okay, now we have one equation with two unknowns, no way to solve, so we are going to write one more equation. By considering the composition of the initial velocity, we can draw a diagram like this. This is the initial velocity u. This is the horizontal component ux. And this is the vertical component ui. I purposely move the ui to this side so it forms a right angle triangle. By this right angle triangle, we know that we can write an expression u square is equals to uy square plus ux square by Pythagoras theorem. So now, when you have these two equations and you compare between them, you know that instantly by comparison, uy square would be equals to 64, and then that means uy is equals to 8. We will know the vertical component of the initial velocity. However, how does that help us to calculate the change in velocity? We are almost there. Let's consider the change in velocity. What is meant by the change in velocity? Firstly, at the beginning, the velocity is like this. Later on, the velocity becomes like this. Okay, so what is the change in velocity? Basically, the change is from the original tip to the final tip of the arrow. So this is basically the change in velocity. When you try to think about, okay, what is the difference between u and v? The difference between u and v is just we have no vertical component, so that's why, okay, it only has ux. There is no ui has been disappeared. Okay, so by considering this, delta v, I'm talking about magnitude of delta v, is basically equals to ui. Okay, so that's why this helps us to calculate for the change in velocity and thus change in momentum. The delta p will be given by m times ui, which is equals to 0.5 times ui is 8. So delta p is equals to 4 kg ms minus 1. Done. So therefore, the answer would be A.